Hey everybody, we're going to take a look at a couple more projectile motion practice problems. These are on Schoology in the Unit 6 folder. They're projectile motion practice worksheet problems. We're going to do number 1. In class, we took a look at some other problem sets, but always check back here. I'll try to video out as many of them as I can and try to let you know when I'm going to be live like I am right now. Feel free as I go along, if you have any questions, you can go ahead and hit the chat button. But this is for projectile motion, again, in the Unit 6 folder in Schoology. So I'm just going to go ahead and bring it up here. Pardon me for my close proximity. Okay, so this is a stone is thrown horizontally at 15 meters per second from the top of a cliff 44 meters high. How far from the base does the stone hit the ground? So we're going to take a look at this from a very straightforward approach. Some of this stuff you might already get, or some of this might be old news to you, but I'm going to walk through the entire problem. Once the live session is over, we will be on a video archive, so you can always come back to this problem later if you want to just review it or take a look at some basic things. But because the object is being thrown horizontally, I know for me that, and I'm going to change my pen thickness here. Sorry again for being so close. I know for me that tells me it's a projectile. Something dropped or thrown is under the influence of gravity alone, and I know it's a projectile. So I'm just going to draw a picture of my stone, and here is my cliff. And I know that the stone is going to follow that arced parabolic path. It says that it's thrown horizontally with at 15 meters per second. So I know that that's the stone's velocity. I'm going to use my picture to help me, so I'm labeling my picture right now. And it's thrown from a cliff that's 44 meters high. So whenever you're looking at word problems, you want to use the words or the context that the numbers come in along with the units to figure out where your numbers go in terms of solving it in a variables chart. So this cliff is 44 meters high. So if this is the ground, for something falling, the ground would represent the final position, and its initial position is 44 meters above that ground. So in the y direction, we have 44 meters high and 0 meters on the ground. So it helps sometimes, and I'm again coming up here, switch my colors. It helps to have almost like an X, Y, like graph or something like that, like a reference point for you to kind of go off of. So the rock's going to fly down and hit the ground somewhere down here. It's asking me for how far. So that word how far, that idea of how far is the final position down here for my X movements. It was up here and it came some distance in the, oh geez Louises, sorry y'all. It came some distance in the X direction and fell some distance in the Y. It wants to know how far from the base of the cliff. So I'm interested in knowing this displacement. What helps also, if you want to do this, this is really your position in the Y. So we can even call this Y initial and this Y final. And then in the X plane, this is your final X position and your initial X position. All right. Because I'm free falling or being dropped or thrown under the influence of gravity alone, I know gravity has a known acceleration of 9.8 meters per second squared. Because I'm accelerating, I need my kinematic variables list. So V final, V initial, X, A, and C. And since it's a projectile, I'm moving in 2 planes. I'm going to do an X table and a Y table here. It also helps if you want to draw the lines and almost make yourself like a grid table, like so. That way you keep all of your numbers organized a little bit better. I can right away fill in the acceleration in the Y direction. It's 9.8 meters per second squared. Since I'm traveling in the negative direction, I'm coming down. It's a negative number. In the x direction, there is nothing interfering with the object. There's no gravity in the x plane, so we have no acceleration. There's nothing else to interfere with it. Because it's horizontally projected, and I showed you guys that video of Wile E. Coyote coming off the cliff. So because it's horizontal, the initial velocity in the x, in the y direction is 0. These are things I'm going to go and do right away. As soon as I get this problem, I'm drawing my picture, I'm labeling it, I'm getting my chart and filling these things in. Now I'm going to come back to my picture and the word problem to get the rest of the information. I can see my velocity in the x direction is 15 meters per second. I can see that from my chart here that the height of the rock is 44 meters. So that's going to come here, 44 meters. It's asking me how far, which means I'm looking for this variable. I can't solve this side directly. I can't go and solve for this because I only have 2 variables. In kinematics, we learned we need 3 of the 5. So I'm going to need all 3 here. In order to get information about time or get some other variable in here, I'm going to need to find the time. Because time is the same in x and y, meaning when this rock falls off the cliff, it's going to hit the ground at the same time in x and y. I can go ahead and solve for time in the y side and bring it over here because my y side has 3 variables. When we do kinematics, we learn to pick the equation. You want to find an equation that you can use to solve for what you're looking for. The best way to do that is to find an equation that has no v final in it because this is the variable I know nothing about. So the equation that has no v final in the equation is that second one on your equation sheet. X final is equal to x initial plus VIT plus 1/2 AT squared. We can take a look at our variables list, and a lot of times this X information that we're given is confusing. So remember, when we did our graph over here, we labeled everything. We're only doing the Y variables. I'm only solving the Y side. The X, the displacement in the Y is 44 meters. It started 44 meters high and fell to the ground. So X initial for me is 44 meters. X final is 0 over here. So I'm going to go ahead and plug that information in. Because VI is 0, so VI is 0, this whole term goes to 0. I don't need to write it. And then I'm going to bring down my 1/2 negative 9.8 meters per second squared times t squared. Please don't forget, like that's t squared. A lot of times when you're writing this stuff out, folks will forget the t squared. So I'm going to go ahead and bring 44 meters over here. I'm doing my algebra, right? So I'm moving 44 over and writing back out my information. Negative 9.8 meters per second squared, t squared. I always multiply the negative 9.8 by 1/2. And this is an extra step here. I'm just doing it to show the math. But again, you don't have to do this step. If you can go right to here. That's fine. Okay, I'm going to divide both sides by 4.9. So 4.9. So of course now I need my calculator. Hold on, let me grab a calculator. Sorry, y'all. So 44 divided by 4.9 is going to give me 8.98. That's equal to t squared. In order to get rid of the square, you got to take the square root to both sides. So if you square root that, well, that should be 2 point something. So it'll come out to be 3 seconds is equal to t. And then just for those of you that need to know or want to know, the units work out as well, because when you divide the 4.9 meters per second squared, you're dividing out the meters, they'll cancel, and you're left with seconds squared. So the second squared is right here. When I take the square root, I'm left with just seconds. All right, we've done a lot of work so far. We're only halfway through the problem. Well, more than halfway through the problem. This comes over here, 3.0 seconds. because time is the same, I can put it on the X side as well. Now I have 3 of the 5 to survive. I can solve. I want to know the position. I know nothing about V final. So again, I'm getting that same equation. X final is equal to X initial plus VIT plus 1/2 AT squared. The cool thing is we're not accelerating over on the X side. Yeesh. Sorry, y'all. Sometimes makes for an interesting video, I guess. We're not accelerating on the X side, so I can get rid of that. And then for the initial velocity, 15 meters per second, time, I've got that one. And I'm solving for the final position because we started out in this X plane, right? I'm looking for this. We started out here, which in this world is 0. So X final is equal to 0 plus, and I'm going to go ahead and solve out. All right, I'm just plugging in right from the chart. 15 times 3, always grab a calculator. You never want to make that mistake. But 45, the seconds are going to cancel. And I'm left with X final is equal to 45 meters. Boom, goes the cannon. Literally, boom goes the cannon, because tomorrow's our cannon lab for those of you in the 6th period class. For anybody else watching, I hope you enjoyed. This is projectile motion, horizontal projection. Please tune in, subscribe to the channel. We will be doing a lot more physics here, going back to kinematics and going all the way through to rotation, simple harmonic motion, waves. We'll get it all in. All right, thanks for watching. I'll see you next time. Now here's the awkward pause because I got to stop the video.